All right, so these notes right here for our introducing our angles, we're going to classify them. We're going to name them, and we're going to talk a little bit about measuring them. Okay? Classifying is like in biology, whenever you have to like name the species and the genus or whatever. I don't teach biology. Okay? This is classifying it, not actually giving it a name, like segment AB. All right? These are your 4 different classifications that we have learned. We just need to make sure we know. So these are the first, other than an angle, which we'll talk about in a minute, the parts of the angle, these are your first 4 vocabulary words for this unit. You need to know these. Your acute angle. You've got it in the picture also. Okay? What do we know about an acute little angle? Its measurement's going to be less than 90 degrees. What about a right angle? It's going to be exactly 90 degrees. Good. So this little box right here tells you what? It's a right angle. That is a right angle marking. So when you see that, you know its measurement is 90 degrees. Good. Our obtuse angle, we're going to be more than 90 degrees. This is your opposite of your acute. And then your straight angle, what is formed there? You got a line, right? Well, to figure out its measurement, let's look at it. We talked about rotations. A full rotation all the way around is how many degrees? All the way around. 360 degrees, right? Well, take a look at here. If we're going here and we're only going that far, I've made half a circle, right? So what would that be? What is half of that 360? 180 degrees. So when you have a straight angle, it's going to be exactly 180 degrees. You will not be told in a problem, hey guys, so angle whatever is 180 degrees. You will be told this angle is a straight angle, and you will have to know that the entire angle adds to 180 degrees. That is part of your vocabulary. Or this is a right angle. You're going to have to understand it's going to equal total of 90 degrees. All right? This is the classification. What kind of angle is it? All right? The next part is parts of our angle. What we're going to do is we're going to fill out the bottom part first, these blanks right here. When we have an angle, we need to see that it is made up of 2 different, what do you think these are made up of? What is that? Not 2 lines or segments, but very close. 2 rays. We have a starting point, and what we call the end point. It's going to go through another point, and it's going to continue in one direction forever. There's one of your rays, and there's your other ray. So this is going to be made up of 2 different rays that share a common or the same end point. So they're going to start at the exact same spot. They're just going to go on and on forever in 2 completely different directions. We talked about opposite rays that form a line. We're not talking about opposite rays anymore. Okay, but opposite rays still share a common end point. So this end point that we have here has a specific name. You may or may not have heard this one. Does anybody know what we call this part of the angle right here? Anybody? What is that? It's your vertex. If you take an angle, let's say, you flip it this way, doesn't that look like a V? So you can remember, kind of help you out with V, vertex, right here. So where that common end point is, this is called the vertex. Very good job. You may have seen in the transformation notes or assignments, I had some students ask me, what does this mean, vertices? And it just means it's the corners. It's right here. Okay? So vertex and vertices is plural for vertex. You'll hear this a lot throughout geometry. So here we have the rays. So what we looked at right here are going to be the sides of the angle. Now our angle it has 3 points, but it doesn't have letters to the points, and we know that points have to have a letter, right? So we can just name this guy A. We'll just make it real simple, B, and C. There is one thing that what's missing on here. It's an arrow pointing to right here. So we'll add that arrow in. When I point to that area right there, that points, what do we call that again? This is going to be that vertex. Okay, I heard a couple new voices there. This right here, this point is creating that vertex. So here's your vertex. And so now what we're going to do is we know that the sides, these other two arrows, they're pointing to the two rays that create the angle. But what we want to do is we want to name these two rays. And if we go back to our segments and our rays and everything, when we take a look at first, let's look at the top ray. Remembering, we want to say the word before the letters. Who can tell me the name of that ray? Ray BA. We start with that end point. And then we go, the second point is going to be some point along the line that ray goes through. So when we have ray BA, we need to remember we have to have that symbol above it. Does anybody remember what happens if I just write BA? What that means? It's not an actual drawing, it's a what? Doesn't have to do with rays, it has to do with your segments. This is going to be your length, your distance. So if I just put BA, I want to know how long the segment is from B to A. So it's another reason we've got to make sure that we're putting these symbols above. So I'm seeing it's ray BA, not an actual measurement. And so then, somebody else, what's the name of my other ray? There you go, I got that correction. Good, ray BC, perfect. With that arrow pointing always to the right. And we put these two rays together. They connect at the vertex, that common endpoint. We have names for these angles, just like we do segments and all other stuff, right? So let's talk about how to name an angle. There are three different ways. One, you're going to see, not to be stereotypical here, but 99.9% of the time. Okay, we'll talk about which one that is. The first one is you can just name it by the vertex. What point is at the vertex? Even if it had points here and here, you can name it simply by just that letter. But you have to say angle and put the angle symbol in front of it. Now, this can only happen under one circumstance, and that's if there's only one angle there, which we'll talk about when we go to the back side of this page. Here, how many angles do we see? One. So we can call it just by that vertex letter if it's there. The angle symbol, you will either see like this, or that's how you're going to see it on papers, on tests, on quizzes. Get your heads up. That's how you're going to see it when it's typed up. I put an arc through it because sometimes, especially when I'm writing too fast, it'll look like a C or an L. So I'll put this through. You do not have to. If you're fine with just that little angle symbol, that's it. I'm not going to take off points because you didn't put an arc through it. You'll see it. Different people do it different ways. Okay? So first, introduce the symbol of angle A. That is how you say. If you just put A, what are we talking about? If it's just an uppercase letter, a point, that's it. So we have to have that angle symbol. So here we have angle A. The next is, I'm pretty sure we made this term up, but point, vertex, point. So with a segment, a line, an array, you have two letters and a symbol above it. With an angle, 99.9% of the time, this is how you're going to name it. What that means is you're going to take a point on a ray, then the vertex point, then the point on another ray with the angle symbol in front of it. What? Okay, let's take a look. Where's our vertex? A. Notice where it says point, vertex is in the middle. That vertex has to be in the middle. When you draw an angle, I'm pretty sure we probably all would draw an angle the same way, right? Like this, right? You need to go in order like that, too, with your letters. We went from a point to the vertex to the point, and that's how we do that. The only freedom you have on that is which of the points goes first. So how can we name this? Angle, what? Who's got our name? C-A-T. Good. Angle C-A-T. T. We went from the point on the ray to the vertex to the point on the ray. Does anybody know how else we can name this? There is another way. What you got?
Angle cat.
Well, actually saying the word cat, yeah, we can. I'll actually do that sometimes. But what else? Angle TAC. Or angle TAC. So you have a little freedom there with the point and the point. What has to stay in a certain place? That vertex has to be in the middle. Okay? Highlighting this one because this is what you're 99.9% of the time going to be using, is your point, vertex, point. Head up, please. You should have a highlighter and be highlighting this. Another way, you don't see it very often, but another way is going to be that interior angle number. If you take a look, the 2 that is inside this angle does not have a degree sign on it. Does everybody see that? It's just the number 2, that's it, no symbols. That is saying angle 2. That is it. So this would be angle 2. If you see a little degree sign on it, which we'll see in a minute, you cannot name it that number because it's now a measurement. But no degree sign next to it, so we could call it angle 2. All right? These are the ways that we can name our angle. It is on the assignment as well. There is one that's going to ask you to name an angle a certain way. One of these, or actually it's 2 of these 3. Okay? So let's go ahead and take a look now, a little step further. So we classified, we named. Now we're going to talk a little bit about measuring angles. Now originally, we had pictures of protractors with rays coming out everywhere, and you had to read the protractor. That is such a pain in the butt, reading protractor. It makes teachers nervous because we always read the wrong side or something. And we looked up and said, we don't need to do that right now. Let's make today, going into the next 6 weeks, simple. Okay, just the basics. What this is about to happen, though, is give you a little bit of an introduction to tomorrow's notes. Okay? So we're going to talk a little bit, we're going to be naming angles and stuff, and we're going to learn now. When we had segment AB and I wanted the measurement, we just said, we just left the symbol away from it. We can't do that here because we take the symbol away from like angle ABC, then we have ABC, which is actually how we name a plane. So we're going to see how to say a measurement rather than an actual physical angle, which is pretty self-explanatory when you write it out. Okay, it's pretty easy to remember. First thing we see here is the angle symbol that you're going to see typed up without the arc, right? So you have angle ABC. We are going to draw ray BD. Okay, so we're going to draw ray BD. Where is that ray going to start? At B even. Bear the vocabulary at our vertex, exactly, because our vertex is point B. And then what I want you guys to highlight here, when we did the segments, I told you guys it's extremely important to pay attention to the words between or bisect or midpoint. Because one meant addition, part plus part equals whole, and the other one meant congruency. So here, this is what's going to come important here. D is in the interior. When you see that interior, we don't know what interior we're talking about. We don't know where. All we know is inside the angle. Inside the angle is this right here. This is outside. Okay? Remember, these keep going forever and ever and ever, so we have to stay inside within those 2 rays. So we are going to draw this ray. Again, we don't know. We know that we're going to start at B. We're going to have to go through what point? Point D. We don't know where point D is, so just go put it somewhere. We know it's inside somewhere, so just go put it somewhere. We know it's not in the middle because it says interior. And then so now we can start at vertex B, our endpoint of our new ray, and we can draw a ray through point D. And what we want to see here is that we actually, how many angles do I have now? Very good. We have 3. We still have the original angle ABC, but now we've created 2 more angles, and we're going to talk more about these angles here in a moment. Big thing to remember, though, here. We named angle ABC, right? When we're naming these angles now, this is where, before we drew that ray in, I could call that angle B. Why can I not call any of those angle B now? What's wrong with me just saying, hey, can somebody go to the board and trace angle B? Which one are you going to trace? You don't know, exactly. You don't know which one angle B would be. No pun intended. Okay? But so now this is the situation where you have to use the point, vertex, point. Okay? You have to use the 3 different letters. All right? Or if they had a number here that said 1 and 2, you could still call that angle 1 and 2. But when we talk about the whole entire big angle we originally had, we'd have to use the letters. And we'll look at all these different things. The next question is saying, is it okay to assume that ray BD right here is an angle bisector? What does bisect mean? What happens when you bisect something? It's going to be in the middle. We're cutting it in half. Can we assume that ray BD is in the middle? That is cutting this angle into 2 congruent parts? No, we cannot. Does anybody know why? Go back to the first problem and what it said. Interior. We cannot assume this is a bisector, okay? The reason why is it said, oops, I have too many letters there. It said interior. Because of that word interior, we cannot assume. The interior is going to be like that. B is between A and C. It's not in the middle. It's somewhere between them, but it's not in the middle. Okay? So what else we can say here is we're going to go ahead and write a statement that says they're not congruent. So we're going to name our 2 angles that we have now created. All right? So we're going to say angle. What's the angle over here on the left? Who can give me that name? Oopsie. ABD. Remember, we can't use B, even though I'm covering up the other ray whenever we go like this. Oh, wait, now we got another ray. So A, point, B, vertex, D, point. A, B, D. We are going to say this is not congruent. Not congruent to what? Use your math words. Good. Angle D, B, C. And watching, we're going angle D, B, C. Point, vertex, point. We're going to continue to use this exact angle for the next couple problems. We're going to have a little bit of writing to do, but we need this in our notes because there are notes. This is our first time seeing it. The repetition really helps out, okay? So we want to write a math sentence about these 3 angles, angle ABD, angle DBC, that we just said were not congruent, and the entire huge angle that we started with, ABC. Well, the first thing we need to do is I purposely did not put the ray in here so that you wouldn't see it down here and be like, oh, I know what this one looks like already. So let's go ahead and draw in ray BD again. If it's not in the same place, I don't care. Okay, so we'll just go ahead and draw ray BD back in here. And this is where I'm going to use the 3 colors. Okay, I'm going to take a look at what I have and what can we look at and kind of think about our prior knowledge and what can we say about these 3 angles. So whenever I trace my angles, when I'm looking at the interior angles, meaning the smaller ones, the one on the left and right that I've created, I'm going to take my color and I'm going to shade it on the inside. Okay, sometimes I'll do it like this, sometimes I'll just trace it. But I do it on the inside. I don't trace the lines because those rays right there are going to share, and I don't want my colors overlapping and getting confused. But here's one of my rays. This is going to be ray ABD. Then I'm going to go and I'm going to trace ray DBC, going with those letters from D down to B, over to C. Okay, so this angle right here. And then the last one is asking for angle ABC, which was the entire whole angle there. So I'm going to trace it on the outside so I don't get confused with all my colors. Now I'm looking right here at angle A, B, and C. Looking at what we have here, what we've done before in the last unit, does anybody know what's happening here? Does anybody see a pattern that's going on? Think about some things we learned last unit. I'm sorry? Okay, so our vertex, right? Yes, it is in the middle. Let's think more along the lines of measurements. Numbers, degree measurements of each one of these three angles. Is there something you could conclude? Is there something you could think of? There's no right angle, but if we look at all three of these, part plus part equals whole. Perfect. This is your angle addition postulate. So we have our part plus our other part, and it's going to equal, and I know the other one's on the other line, but your whole. So if you have a part and you have a part, you put them together right next to each other, we're going to learn adjacent, it's going to equal the entire thing. So I do apologize if you are colorblind, but with my colors, all this means is pink plus blue equals the purple, the entire purple angle. Okay, that's what happens when you have a ray going in the interior of that angle. So we're going to write this out as a math statement, but now we're looking at numbers, so we're not saying this angle and this angle equals this angle. Okay, we need to make sure that we are writing. Pay attention. Edmund. So now we're going to say the measurement, and all you have to do to show the measurement of the angle is put a lowercase m in front of the angle's name. So for instance, the measurement of angle ABD, all we would write, and I would suggest kind of starting over here because we do have to write a bunch of letters out, we have the measurement of angle ABD. So the only thing you're doing is throwing a small little m in front of it, and that now tells you measurement, Jason. So we have the measurements, we're writing out the same. We want a math sentence explaining this. Part plus part equals whole. So we have the measurement of ABD plus the measurement of angle, which one? DBC. Notice that I also have my corresponding colors. What does corresponding in math mean again? Not the same, but matching. Okay, it is saying yes, but we want to make sure that we're using that word matching. We'll understand as we go through the year. So if you add these two together, this will equal what? Measurement of angle ABC. Good. It's just a part plus part equals whole. And we're going to put it into play now. We're going to look at it and see what exactly is going on. I'm not going to make you redraw the angle, okay, or the angles, should I say. But for note purposes, now that we've gone down to another problem, we're going to see in tomorrow's notes that the first problem we're going to have is it's going to give you steps, bullet point steps of what to do. Because we started having some problems where you guys would do your work, but you wouldn't draw the figure. And that's where we started running into some problems. Because then, especially if you have to substitute back in, you don't know which one you're substituting in for. So we are going to have the first step of drawing it. Well, we're not going to draw it this time because it's up here. We're going to want to label with our degree measurements, but then we're going to want to write a math statement. Again, it's going to be exactly this. We're rewriting this exactly down here. If you don't want to use separate colors, don't. Okay, I'm pretty quick with switching the pens because I got lots of years experience with this. But first thing we're going to do is we're going to write the math statement. We're going to substitute in for the values that they give us, and then we're going to solve. Okay? So here we will have again, I'm just rewriting all of this. So you could already be writing this right now. We're just rewriting all of this. The measurement of angle ABD plus the measurement of angle DBC. And you don't need to be looking at mine because you've got it right here in the problem right before it. Is equal to, or you should, the measurement of angle ABC. And then let's take a look at what the problem gave us. The measurement of angle ABD, the first thing they gave us here, is 42 degrees. So I'm going to substitute in here. So for measurement of angle ABD, I'm going to put 42 degrees. Then we will add, the next thing they gave us was the measurement of angle DBC. So DBC, which is right here, the second one, the other part, right, is going to be 64 degrees. This will, in the end, add to equal the entire angle ABC. Anybody off the top of their head know what 42 plus 64 is? Good, 106 degrees. Even though it said, what can you say about the measurement of angle ABC, I want to add in something else. Because we were talking about classifying and naming. So again, these three dots I'm going to write are just meaning therefore. So since the whole measurement of angle ABC is 106 degrees, we can say that angle ABC, the whole part, classify it. What kind of angle is that? 106 degrees. This is going to be an obtuse angle. There I am shorthanding it like I do MDPT for midpoint. I will put the angle symbol in. I am perfectly fine with you doing that. It takes less time than writing the word out. So even though it did not ask to classify, I do want to make sure that we're keeping that in our head. Okay, so we can see all what's going on. Okay?